Hey everyone, it's Actuary Dude over here looking at another question. So, a company has agreed to build and operate a toll bridge for regional government. The company will invest £10 million per annum for the first 2 years of the project, the investment being made continuously during this period. The bridge will then come into operation and the company will start to receive payments at the end of each year, so that's in arrears, the end. The first payment occurring at the end of the third year of the project. The amount of payment at the end of year 3 will be £8 million, reducing by £500,000 each year of the subsequent years until the annual amount is £3 million, after which the annual reduction will be £1 million. When the payments have reduced to zero, the company's involvement in the project will end. So we need to find the net present value at a 10% per annum effective interest rate. So fairly easy to do. We'll just find the positive and negative cash flows at the present value and sum them together. That's how net present value works. So first bit's relatively easy. These are the negative cash flows and the only negative cash flows in our problem here. So it is minus 10 million occurring, and that's happening twice, so one each year over 2 years, and it's being done continuously. So that was 2 years, 10 million a year continuously. And that's really it. So then we're done with the negative cash flows. Now we can look at the positive ones. With regards to the positive ones, we're looking at this and noticing that we're going to have to do two calculations here, because one, it's reducing at $500,000 a year, and then after that it reduces by 1 million per year. And when we're going to be discounting, we're going to be looking at discounting this sort of area over here, because this will be one problem as it's all discounting by $500,000, and then this will be its own one. But once we've discounted it, the present value for these ones here will end at this point, and then these ones here will end at this point. So we'll then have to discount this back 2 years and this one back 12 years. So to start with, we're getting actually 3 million a year for each of these years, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 payments. So all we have to do is say that we're getting 3 million a year in a regular annuity over 10 years, and that's pretty good. And then we've just got to, now that we've brought that down to here, we've got to discount it back 2 years. So we'll just times it by v squared. And now, what about this bit where we started at 8 and it's going down $500,000 each year? So the way, as opposed to an increasing annuity with a decreasing annuity, I'll just note the formula down over here, it will look something like n minus a regular annuity divided by I. And that's how it's going to be looking. So in this case, and then what we'd be doing is we'd be multiplying it by some sort of cash flow amount. So over here we'll be doing 0.5 and then decreasing annuity, dA, over 10 years, and we're going to have to discount that back again 2 years times v squared. And then the next bit we don't really have to add up anything, because what a decreasing annuity does is it just brings its value down to zero straight out. That's what it's doing. So for all purposes, this bit over here has really just assumed that we're getting 10 payments and we're actually starting at 5 million, really, is what it thinks. So it's starting at 5 million, then that will bring it down to zero. And this is that 3 million extra that we're getting. So over here, it's going to assume that we're starting at 3 million, and it's just going to bring that one down 1 unit at a time over 3 years. And then we've got to discount that back down 12 years. So multiply by v to the 12. And then we've just got to work that out using Excel or your calculator or whatever and find out what that present value is. So let's bring Excel onto here. I'll see if I can get it up like that. And alright, let's do some calculations. So I'll find out what delta is, I'll also find out what v is. I'll note down what I is just for the sake of it. V is equal to 1 divided by 1 plus I, and delta is equal to the natural log of 1 plus I. Okay, so the first bit, the first cash flow that we've got is this bit over here. So that is going to be equal to negative 10 times our continuous annuity, which is 1 minus v to the n, in this case n is 2, all divided by delta. And that's what it is, that's our negative cash flow, so that's fairly straightforward. Then our next bit is we'll find out this part over here. So that is going to be equal to 3 multiplied by 1 minus, this is a regular annuity, V to the 10 periods, divided by I, and there we have that, and then we're going to multiply the whole thing by V squared, because we've got to discount it back to the present value. Sorry, I've done too many brackets somewhere, so that's that, that's that, we don't need that, brackets over there. There we go. And then we can add on this decreasing annuity bit. Now that one's got a few more steps in it, so we're doing 0.5 multiplied by, now the formula for the decreasing annuity is then going to be N, which is 10, so over here, minus a regular annuity, which is 1 minus V to the N, which is 10, again, divided by I, and we'll close that, close the whole thing, and then divide all of that by I, which is, there we go, right there. And do we have to discount it again? Yes, 2 years. So times V to the 2, V squared. And that's that bit there. So first and second, and now lastly we just have to find one more decreasing annuity, and then we're good to solve this. So that is equal to 3 multiplied by, and same thing that we had before, it's going to be N, which is 3, minus a regular annuity, 1 minus V to the N, which is 3, divided by I, which is that bit, and then we put all of that inside of brackets and divide everything by I, and there we have, now we've just got to discount it back 12 years, as we can see, to bring it back to present, times V to the 12. Okay, and now I've just got to sum all of this up and see what I get. And the answer is 17.86. So I'm just wondering if there's anything going wrong over here. So everything looks to be okay, but there's something wrong in this one. Here we go. We don't need to multiply this by 3. And the reason for that, the reason we didn't need to multiply that by 3 is because it's already done that calculation for us. It's already reducing it by 1. That value there is how much you're reducing it by. Like over here, we're reducing it by a half. So just got to keep that in mind, that it's very different to an increasing annuity. So the answer is 14.59 million pounds. And that's the net present value. So thanks a lot for watching.